6.6, we have two different videos for 6.6. So when we're talking about functions, remember the f of x, this g of x, that's just basically naming. The only reason why those letters are there is saying the different name. Like this could be Bobby, this could be Jill, or Jack and Jill, because they went up a hill to fetch a pail of water. You remember that? So we're just going to go through these, but one thing that we have to be aware of is if we are dividing by something, this whole equation can't equal 0, because then that would be undefined when you're dealing with division. Adding, subtracting, and fractions first, or functions first. So again, this is just naming this function of f as this whole equation, this function of g is this whole equation. When I add the two together, it's taking this first equation, so my function of f, and add my function of g. And then once you do this, if there's any like terms, you have to combine like terms. So in this case, these two are like terms. I combine those, and I would get 5x, and I'm going to put this in standard form, so you should put your x's first. So this would be my adding part of the problem. So now when I'm subtracting, you just have to be a little bit more careful. So I'm taking my function f, still this right here, my 4x plus 7. You're subtracting your whole function of g. You have to make sure to put this in parentheses. Here's my function of g, it's the whole function. You have to distribute this negative in. One thing is that a lot of times people make the mistake of, they forget this parentheses and they do not subtract the whole function. So I have 4x plus 7, subtract square root x minus x. So again, combine like terms. And this time I have 3x and then subtract square root x plus 7. Pause the video and try to do B by yourself. Here when I'm looking at my addition, here my 2x squared plus 8x plus x minus 3. I can have 2x squared plus x and then combine my 8 minus 3. With subtraction, you have to, again, make sure to distribute that negative through. So this becomes a negative x, and this becomes a positive 3. That changes your last two terms. Now, what if I'm, multiplying and dividing? So if I'm multiplying here, this is still saying multiplication. This could be the same thing as this. These two things are the exact same, okay? So when I multiply, I'm taking my x squared minus 9 and multiplying by my x plus 3. You can either do box method or you can FOIL this out. So my first would be x cubed. Outside would be plus 3x squared. Inside, minus 9x. And last, minus 27. If there were any like terms at this point, you would want to combine like terms. But in this case, there's no like terms. So this is my final answer. Now when I'm dividing, here is my function of f on top, so x squared minus 9 over my function of g, x plus 3. You first want to be able to see is, can you factor anything? I can factor this top. I can factor that to be x plus 3 times x minus 3 over x plus 3. When you're dividing, now I want to see if there's anything you can cancel. You can only cancel if it's multiplication in between two things. So these are the exact same. So I can cancel out the x plus 3 over x plus 3. So now I have these two cancel. I'm just left with x minus 3 as my final answer. Bing, bada, boom. Try to do B by yourself. Pause. So for multiplying, I chose to do it with the box method this time because I have a trinomial times binomial, and I just feel like it keeps it more organized. So I multiplied each term. The other reason I like the box method is because typically your diagonals, right here, will be like terms. So 3x squared minus 33x squared gives me negative 30x squared, and negative 11 minus 12 gives me negative 23. Now when I'm dividing, here I can factor this. Now, one thing you can look at what you're dividing by, a lot of times that will be a hint on what you could factor. So I can factor this into 3x plus 1 and x minus 4. So if I checked my outside, this gave me a negative 12x. My inside gave me a positive 1. And together, that gave me a negative 11. So that was completely factored. Now I have, can cancel both of those out, leaving me with just x minus 4. Now, just in case, let's say if I had something like this, if I had the function of g divided by the function of f. So my equations are still the same. my function of g would be the 3x plus 1 over 3x plus 1 because we already factored x minus 4. What happens if it's this case? Well, these two still cancel each other out. However, this is on the bottom of the fraction. It should stay there. So this answer would be 1 over x minus 4. See how when you flip these, it can be a different answer. And last but not least, what if we just had arithmetic with our functions? So if I'm looking at saying my function of f is here, my function of g is here. So it's saying 4 times my function of f. So I'm going to have a 4 times my function of f. And then subtract 2 times my function of g. So I'm going to distribute my 4 in and distribute my negative 2 in. So this becomes 12x squared minus 44x minus 16. This becomes a minus 6x, and this becomes a minus 2. Here I have 12x squared, and these two can combine because those are both x's, so negative 50x, and these two can combine because they're both numbers, minus 18. And that would be my final answer. And that is all for the 6.6 part 1. Have a wonderful day today.